Hi all. So graph coloring. I'm going to do 3 problems. I only assigned the 2 special problems, but I want to do this one, perhaps 2, in case that some problems with it. So this is the original problem actually of the 4 coloring problem. And what you need to do is first make the so-called dual graph. And that is a graph whose, I'm doing it below, so I'll do it there. The vertices are the regions A, B, C, D, E, and F, and we have an arrow, an edge, if their borders touch, if they have common border. Now A and B have a common border, so that's for sure. Then B has a common border with both C and D, and A, of course. And then C, apart from what I already did, C has a common border with E, so I'm going to go this way, and D has a common border with F. So again, although we don't need to, we know that we can make this in a planar graph, meaning a graph without intersections. It's not necessary, I'm just saying that for information. And now we have to start trying colors. And so this could be a bipartite graph, so it could be 2 colors. So we should try that first. Can we do 2 colors? So I take green and red. Let's try these ones in this order. And I can choose wherever I want. I'm going to take B because I feel like B has like a lot of options. So perhaps that will determine quite a lot of stuff. Let's see. Now, if I take, I'm trying to show. So, question is the chromatic number of this graph 2? That's the question. If it's 2, so remember, what you're doing is you're making a decision tree. Although I don't want to make the tree. I'm not talking about the graph itself, right? By backtracking, I'm doing backtracking. Let me put it that without saying about the tree. I'm doing backtracking trying to use 2 colors. And if my backtracking fails, then I know I need 3 colors. And if that fails, I know I need 4 colors, and so on. Okay, so I start with taking green, and now I'm trying to do as much. I'm trying to do it with 2 colors. So, and to be systematic, I'm going to go alphabetic. I know I didn't start with A. I could have started with A, but I'm going to go alphabetic from now on. So, in other words, A. I know that A, I cannot choose the first color, but I can choose the second color, which is, of course, obvious always, right? So, yeah. So I'm taking that one. And the next one I can do, of course, I'm also, although I work alphabetic, try to figure out what is what colors I can give. I always want to make connect, right? I don't want to color this without knowing any of its neighbors yet. I only want to color things of which I have already some neighbors. So what about C? Okay, C can be colored, but it has to be red. D can be colored, but it has to be red. That's it. Okay. Sorry, that's not really. I'm not really backtracking here. So let me go back here to. No, it's fine. It's fine. No. As long as I can go. No. Sorry, them is correct. So the next one I would go is alphabetically E. Can I color it? Yes, I can. I can make it green. And then finally, can I color F? Yes, I can make it green. So we see actually this 2 here. So this actually is a bipartite graph. So this checks out. This is bipartite. And so, in case you wonder what is the partition, B. This if A is a sea and B is an island, and then there are 2 lakes in that island, and then E and F are islands and the lakes on the island. I don't know. So, and the other one therefore are all red, which I perhaps should make blue if I'm saying that these are water. So you could think of this as water and land, and that's bipartite. Okay, so that was that. 8. That was one of the special problems I assigned. I have to make sure that I draw the same graph. there are two more vertices, right? Yes, here and here. So this A, B, C, and D. I keep the same naming as the book. And then we have this, and then we have these two corners connect, these two corners connect, and then E connects with B, and C connects with F, and then A connects with D. Okay. Well, let's see. Perhaps it is bipartite. So that's the thing. We cannot know. You cannot see whether something is bipartite or not. So the first thing is this 2. So again, our colors are red and green. So I'll pick one edge. Doesn't matter which one I take here. So let me take this red and then the other one green. Okay. So alphabetically again, I'm trying to get a color to C. And I cannot take red, but I can take green. So that's good. Can I color D? Yes, by coloring it red. Okay. Can I color E? No. If I color E, then I need a new color. Now, notice that when you're trying to color with 2, there is not really a backtracking, because each time you have only one choice. You're always looking at a vertex that is already a vertex connecting to one of the colored vertices already, and that always has to use the other color. So there is no choice, never is there a choice, and therefore there is no need to backtrack here. So we see here that at this point, trying to color E requires a third color. So I know I cannot do it with 2, so I'm now going to the question, can I do it with 3? Now I will, it starts the same, right? Because I'm always trying to get the colors. Remember the order of my colors was green, put it up here, green, red, and blue. And so far I have up to E, I have still followed the procedure that I always go to the first available color. Okay, and now I have to use the third color. So now what about F? Now I see that F cannot be colored because with blue, but with any of the 3 colors I have, because there's a green, a red, and a blue neighbor. Does that mean that I cannot do it with 3? No, because there were choices now. Because the first thing I can backtrack is, well, I can backtrack to E, but there was no choice. I had a new color. So E, that is not a choice here. Okay, I have to be careful. But in D, I had a choice. I picked the first choice I could make, which was red, but perhaps I should have taken the next color, right? When I originally started to do optimal, in a sense, I always try to do the first colors used as one of the. I order my colors and I always use the first available color. But if that doesn't work, I have to go to the next possible scenario, if there is one. And there is still one. When I chose D to be red, I could have chosen D to be blue. And so this is something that I now have to consider. Okay, let's go to E. Now, this doesn't change what happens to E. E also has to be blue, fine. But notice that something has changed now. F can now be colored red. So I did improve somehow. I'm not saying that I'm going to make it, but at least I got a color for F. Oh, actually, what am I saying, right? Because that's it. Oh, by the way, I'm so sorry. I actually noticed now, because of this extra edge here, I didn't pay attention to this edge. I put here red, right? That was not even allowed. So what I actually showed is that this is correct, so this color is 3, but I showed even if I remove this one, it's still 3. Okay? And the coloring that I originally did by making this red won't work, but this coloring works. Sorry, I actually made a mistake in the sense that in my previous coloring, which is now not visible anymore, remember I drew this, there is this edge here and I made this red, which was not allowed to. I apologize for that. But I'm not going to do it over again. I hope you see. Okay. And then finally, this is the question about scheduling. That was number 17. Okay. Now the challenge here is a little bit more putting everything in a graph. Okay. So we have various courses. They all have different numbers. So I'm just going to use the 115. There's a course called 116. There's a course called 185. There's a course called 195. There are math courses, I know, and then there are computer science courses, 101, but they have different numbers, so I don't care about that. Computer science 102. What else? And 273. And 273, and 473. Okay. And now the information that we have is there are no students taking both, so we get a negative information. And that is a little bit annoying. Is there no? So how do you do this now? So what we're going to do is we're going to make the complementary graph first. We didn't really talk much about complementary graphs. I'm not saying that's the only way you can do it. You can do it otherwise. But so that you don't make, the best way to not make a mistake is I'm going to first make the graph where I'm going to put an edge when two classes do not have anything in common. Okay? That's not the graph I want. I want the graph where they have something in common, because then I will color that graph. So I'll do I use gray here. So I'm making here this is what the complementary graph. So in this case, we know that there are no students. So now I just go to all the information I have. No students between 115 and 473. So I know there are none, but gray is not a good choice. Let me use red here. It's much more visible. Okay. There is no course between 116 and 473. So that's that. 195 and 101. 195 and 101. 195 and 102. 195 and 102. 115, 116. 115 and 185. 185 and 195. What happened to 273? Did I miss something? Yeah, okay. So this, wait, I'm make sure that I have all the information. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So these are the non-connections. Now the actual graph, so this is the complementary graph in red. The actual graph is exactly everything else now, all the other edges. So you look at the complete graph and look at all the other edges. Now that is quite a lot, of course. So I'll make them in green. So that means from 115, what are the ones? Well, there is one there, there is one there, there is one there, and there is one there. Okay, 116. 116, there is one here, there is one here, one there, one there, one there. 180, well, let's go 473. 473, there is a, let's see, there is one here. That's gonna be, I'm gonna go around because I'm worried that I'm not gonna see this anymore. Okay, and then there is one from here to there. There's one from here to there, and one from here to there, and one from there to there. Okay. Where am I? 185. 185. There is still one from here to there, and from there to there. I hope I. This is the danger that you're gonna miss something, right? And then let's see. What's the next one? 273. Yeah. So there's one here. There's one here, and there is one here. 195. No, there's nothing else anymore. The only ones left are these two, right? That I have now for 195. Everything else I've considered now, but both are have nothing in common. So 101, there's only this one, and there is actually one. Yeah, okay, so we have one more. Okay, so you're bound to make mistakes here. Now let's think about this. If you take the complementary graph and then the other one, if you put them together, you would have the complete graph. Okay, and how many vertices? 1, 2, 3, 4, 5, 6, 7, 8 vertices. And we know that a complete graph means that every vertex is connected to every other vertex, either by a green or by the red. And so altogether it means every vertex has to have degree 7. Otherwise we forgot something. So let's go quickly double check this. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. There we go. What are we missing? Oh, yes, I see. 185 and 16. Oh, no, you have that. 185 and 473. Yeah, we have that. 185, 273, 185, 101. That's the one I'm missing, right? Yeah, because, right. So 185, 101. You go there. See, that's how we can find them. So now let's continue counting. So 1, 2, 3, 4, 5, 6, 7. Yep. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Oh no, this is also 5, 6, 7. Yeah, this is bad here. They're kind of, this is not a good draw here. This one I have to redraw this because it kind of conflicts with the other one. So okay. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 6. What am I missing again? What am I missing? Oh, how much is this one? 1, 2, 3, 4, 5, 6, 7. That's not possible. Remember, it's a graph, and so wait, I make 1, 2, 3, 4, 5, 6, 7. I don't know what I was doing. It was correct. It's correct. I have it now. Okay. Very unlikely that it's bipartite, so I'm already going to ask myself: has this graph? Is this 3? If it's 2, then I would even find it, right? So because I'm always going to try to do the perhaps I should not take these colors. I'm going to take different colors because otherwise with the red and green already it's gonna. So let's take blue, orange, and something. What other shade do I have? I guess I have to do purple. It's different enough, right? Okay. So we start with 1. Now remember, it's the green one I should look at. Perhaps therefore let's erase the red ones. Otherwise we get confused. So this is now the graph that we have to color. I hope that I didn't make many mistakes. Let me quickly go over it again. I didn't erase anything else, right? Yeah, okay, I think I did it correctly. So I'm going to do it one more time. I have to make sure that I don't delete any green. Okay, I think I did it. Okay. So I'm going to choose something. Well, let's take one of the edges, 115. I'm going to take this edge here. So I'll have to do blue first. I'm going to make this blue, and then the one below there, I'm going to make... Oh, no, I was going to go alphabetically. So 115, the first... Well, alphabetically, not alphabetically, left to right, top to bottom. The first one I can take is actually 273, so this one. Okay, so what's the next one? I can connect to 273. I can connect 116, and I can do this using blue. Okay. Oh, that's not blue. Okay. The next one, 473. That's now also connecting, and I can also use blue for this. Okay, that's great. Okay, the next one is 185. It is now connected, so I should look at 185, right? So 185 is connected as so far only one blue, no, be careful. See, now we have to be careful. 185, it does connect to the yellow and it connects to the blue, so I will have to use my third color. Purple. Oei. Purple, okay. Next, 195. 195 connects to two blue and to another blue and to orange. So I have to use purple here. Okay. 101, what does it connect to? It connects to 101 connects to a blue there, a purple, another blue. Oh, it connects to yellow. So how far should I backtrack now? Okay, let's see. In the previous case, 195, there I had no choice because I had to use the third color because there were already a blue and a yellow neighbor. So if I backtrack there, I have to go even further. In 185, again, had no choice. So again, there I backtrack. Now in 273, no, that was the first one I took. So sorry, that's a bit confusing, but that's what the first one I took. Then the 473, I made that blue because that was the first color available, but perhaps that was not the wise choice. So I'm backtracking to that one and now making it purple. Okay. Let's see. What is now my choice of 185? 185 now is connecting to three different colors. 116, 473, and 273. So that is also not working. So I backtrack that one. What else can I do? Well, 116, I colored that blue. That was the next choice that I did, right? So let's backtrack to that. What can I do? I could take the other purple color. Okay, so now back to 473. What can I do with 473? Well, 473, I can now make blue again. I could also make it purple, but let's always try the first possibility. We know that we look at everything. So we do make this blue. Then 185, it's now connected to a blue, a purple, and a yellow again. So no. So I have to backtrack. So I had a choice in 473. I could make it purple. So let's see what happens if I make this purple. Okay. Now, 185. 185 connects to a purple, two purples, and one orange. So I can use blue now. Okay, so that's